your peers whether you are good or bad or not so good or not so bad. Are we clear? Okay, I'm not very proud of it, but you know, that's the benchmark now. We clear? So next term do well, okay? Right. So y as a function of time now is equal to 8.972 C1 cos 8.972 T, okay? And then we have minus 0.333 bracket 8.972. Then you have sine 8.972 T, okay? And then plus 52 times 10 to the power minus 3 multiplied by 4 cos 4T, okay? So we're going to substitute okay, so when you put everything in, you get 0, and this will be equal to 8.972 C1. And then you have what? Plus by what? 52. The interesting part is no one asked what you get for 1P13. Can't tell, man, 1P13. Every father, mother, son get A. I don't know whether you're good or bad. Is it still like that? 1P13? Everyone get A? Go. So from here, at the end of the day, we get y as a function of time. This will be equal to C1 minus 23.183 times 10 to the power minus 3 sine 8.972 T plus 0.333 cos 8.972 T plus, is it all plus? Do I have minus? Oh, no. The first one is minus. Plus 52 times 10 to the power minus 3 cos what? 4T. Put a big bracket. The answer is in feet. So how do I grade you from here? If this one, you get it right. Okay, this number, you get 1 out of 1. Over here, you get 1 out of 1. Yes. A pint of beer. Yep, and if I wrote this as cost, you get marks deducted. Okay, so I got my marks deducted, but unfortunately, I got my degree already. Okay, we clear? Crystal clear? Is force vibration more difficult? It is not. Are we clear? Okay, it's like easy peasy. My doctor tell me what? Slimy and limey or whatever. Are we clear? Limey and slimy. We clear? Right. The next question that I'm going to do is the one that I did on last Thursday where the explanation is really crappy. Okay. And I personally, what do you think about this question? Is it a good question? Nice question, isn't it? Right? It is a nice question. Okay. I'll tell you what's so nice about it now. Okay. It's a question that confused you and me. Okay. And I hope to do a better job this time. Right. I really hope to do a better job. The last time, yeah, I hate that room over there on Thursday. Do you all like that room? Yes or no? I hate it. You know why? It's too romantic. The lights were like yellowish, the mood really. Right. So let's look at this question. And as I said, I do apologize. I did not explain it really well. After I went back to my office, I looked at my video. It is really what? Really bad. Okay. So I hope to explain this in a better way so you can understand better. I think that is more important than anything else at this moment. Right. So if we were to look at this question, right? Over here, so this is what is happening is you have a pulley, or you have on the left-hand side, you have a motor. Okay. And then on the right-hand side, you have a pulley. Okay. Pulley CD. Okay. And pulley D is attached to the mast. Okay. Or to the, what do you call, to the block. And the block we are given down here, the block is written down as what? As B. Okay. So from here, we will write down, from here, we will write what we know. Okay. So what we know is that given to us, right, omega A is equal to 3 radians per second. Theta is equal to 0. S is equal to 0. Now, all this is where time is equal to what? 0. Now, where I get the expression where time is equal to 0? Anyone? What would tell me that this is at time is equal to 0? Anyone? What tells me that this is time equal to 0? The word what? Starts. Yes or no? The word start. So the word start, so this is from what? Starting at. Are we clear? Okay. So we are also given pulley A is equal to 0.6 theta radians per second squared. Okay. So next, we are going to determine speed of block. So we are going to determine VB. Okay. And we are going to determine VB when S is equal to 0.5 meters. So what is S? S is this distance over here. Okay. The pulley has an internal hub D, which is fixed. Okay, they highlight fixed to C. Okay. So over here, we know that A and C, or A, C, D, okay, generate rotational motion. What were you drinking? B, you have what? Linear motion. Okay. So one thing that we can also add, okay, so remember this is a rigid body. Okay. So we know that A, okay, this is the motor on its own. This is our rigid what? Right? Rigid body number 1. Right? Over here, this is our rigid body number 2. We cannot use the famous 5 equation because the acceleration is non-constant. Okay, so the famous 5, you can, is it famous 5 or famous 3? Famous 5, right? So now they become not so famous. Can't use them anymore. Okay. So a lot of, so what you see down here is lots of information are given at what? At A. Okay. Not much information are given us in C and D. Okay. So the first thing we have to do, okay, we are going to consider, okay, we are going to consider pulley CD and the mass and block B. Okay. So you sketch this out. And if you were to look at the motion, okay, and if you were to look at the motion, right, this is a string. This is our block B, okay? And over here, this is our pulley. And this is our pulley D, okay? And pulley D, we know pulley D has a radius which is equal to what? 0.075, okay? And we are aware, right, that over here, we have a what? We have a, so let's say pulley, so initial position, and over here, we will rotate, this is our theta D, right? Now, in terms of displacement, from here to here, if the motion is up to here, is equal to S, right? Right? What we have is the block, if this is our ground, this will also move by what? S. Okay. And we are aware that over here, this will rotate by what? Omega D. Okay. So from here, you can bridge a few relationship already. Okay. So what can we write? Okay. So we can write this relationship. We know S will be equal to theta D multiplied by RD. Okay. Because S over here, no doubt is linear at B or based on the block, but on the pulley is also our what? Is also our length. Okay. Right. So from here, okay, we can also write out the relationship where BD. So I'm going to draw another vector over here. This is our VD. Okay. And this is going up. This is also our VB. So from here, we can write out our relationship where VD is equal to omega D RD, right? And this is also equal to our VP. Okay. So what we don't know is we don't know what is what? Our what? Omega D. Okay. Anything else to analyze? The answer is no. Now we sketch the pulley now. Okay, now we sketch the pulley and the motor system. Okay, so next we consider a motor at A and pulley CD. Okay, so when we sketch this out, right? So this is the motor at A. This is our pulley CD. Okay, so when we draw the line, and as I said before, assuming that no slip occurs. Okay, so that's motor A, pulley CD. So we know that this relationship is true. Okay, so all these lines represents the velocity. So over here we have our omega C, and we have our omega what? Omega A, right? So now we know we can reach a relationship, right, where velocity at C will be equal to the linear velocity at A. Okay. So here on, we know that we can write the relationship tomorrow. I'll see you. Tomorrow, 9:30.